All right. Good morning. It is day 13 of Advent of Code. That is some delicious coffee. All right. Let's jump into it. Claw contraption. Next up, the lobby of a resort on a tropical island. Historians take a moment to admire the hexagonal tile floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines. Claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons labeled A and B. Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 to push the B button. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time the button is pressed. Each machine contains one prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axes. You wonder, what is the smallest number of tokens you would have to spend to win as many prizes as possible? You assemble a list of every machine's button behavior and prize location, your puzzle input. Okay, so this interesting. Okay. This feels like pathfinding, where button A has a cost and button B has a cost, but you're not just moving one tile over. Each machine contains one prize. Oh, okay, that's the coordinate that you have to be over. Okay, this seems pretty tricky. This list describes a button configuration and prize location of 4 different claw machines. For now, just consider the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along X and 34 along the Y. Pushing B would move it 22 along X, 67 along Y. This means that from the claw's initial position, you'd need to move exactly 8,400 units along the x-axis and exactly 5,400 units along the y-axis to be perfectly aligned with the prize in this machine. Oh, maybe this is in pathfinding. This seems like... I don't know. Cheapest way to win the prize would be pushing the A button 80 times and the B button 40 times. This would line up the claw along the x-axis because 80 times 94 and 40 plus times 22 is 8,400 along the y-axis because 80 and along the y because 80 times 34 plus 40 times 67 is 5,400. Doing this would cost 80 times 3 tokens for the A presses and 40 times 1 for the B presses, a total of 280 tokens. For the second and fourth claw machines, there is no combination of A and B presses that will ever win a prize. Okay. For the third claw machine, the cheapest way to win the prize is by pushing the A button 38 times and the B button 86 times. You estimate that each button would need to be pressed no more than 100 times to win a prize. How else would someone be expected to play? Figure out how to win as many prizes as possible. What is the fewest tokens you would have to spend to win all possible prizes? Holy moly, I don't even know how to start. So I suppose I could have the maximum number of presses for in the X direction of this. If I did 10, that's, if I did like 100, that's 9,400. So that would be too much. So I would have a maximum number of presses where that number would go over. I don't understand what they're talking about. Hexagonal floor tiles. Seems like that's irrelevant. Or maybe that's just a throwback to a previous, 2020 day 24. Claw machines here are a little unusual. Instead of a joystick or directional buttons, you have 2 buttons. Forward along the y-axis and right along the y-axis. I have no idea how to get started, but I'm going to start by parsing because that's at least a way to get going. Let's make sure that let's see, day 12 was yesterday. Let's push that solution. Okay, why didn't Xcode open? Weird. All right, so let's add our 13 here. Then we will go grab day 13 main and tests day 13 tests. Parse. This is going to give me, let's see, we'll have, what do they call this? The claw machine. And then we've got the A gives us a point. And B is a point. Let's see, button A gives us a point, and then we've got a prize, which is also a point. All right, so that should give us our claw machine. We're gonna do, and we need to actually get many claw machines, right? Yeah, so separated by a new line. So if we start with the claw machine parser, let's do this where we do static func parser, returns a parser of self. Okay, remind me later, I'm streaming. Okay, so this one is protocol parser specialized with too few types. This is a parser of substring? No. I'll figure that out in a second. This is going to parse with a, we're going to get button A, colon, and a space. And then it's going to be x plus, then an int.parser. If we take a look at the int parser, that returns parsers.int parser, which is of type parser. Oh, I guess you have to specialize the generics there. I don't know. I think we'll figure this out as the return value when we're done. So if I did like int, this says I can't return this thing. I think I want to do any parser of claw machine so that I don't have to do that, and then I can do erase to any parser. Let's see. We need the input and the output, so this will be substring claw machine. Input, output, yep. Okay. Cannot convert expression of type any parser, substring. Not sure what I'm missing here. Let's jump over to the docs. I suppose I could do some parser here, right? Okay, so then this is button B gives me, oh, sorry, that needs to be a comma and a space, Y plus. Button A, button B. So I think that is going to be I'm tempted to make this a point parser as well. Let's do return. Let's do a point parser. So that's going to parse. The input is going to be substring.self. And this is going to be x followed by one of plus or equals. And then an int parser. Then a comma, space, and then the same thing for y. Okay, so now I can say button A. Sorry, that needs to map the int to a point. $0, $1. Okay, so button A is now going to be a point. Then button B is going to be a point. And then I think I need a new line. White space, one vertical. Vertical. Then we will do a prize point, white space, one vertical. Okay. I think that should work. So that gives me our point parser and our claw machine parser, and now we can say that we have many claw machine.parser separator white space 1 vertical. And then that's going to take our input, and we need to transform this result. That's going to give us our claw machine. Actually, no, this needs to do that. This needs to map our claw machine with A, B, and prize. Okay, so then this one does not need to map at all. Referencing instance method on parser requires that never conform to parser. All right, what am I missing here? I think this might be wrong. So I feel like those types are important. Yeah, okay. Try, that means this can throw. Okay, let's give this a test. We're going to say parse claw machine throws. Input is going to be, let's just grab a couple of these. And as is usual, I want to do trimming characters in white spaces and new lines, just so I start with exactly what I think the input will have. And now we'll do machines. We're going to expect that the machines count as 2, and that the machine 0 to A is 5111. Yes. 3878. Cannot find a point. And then the prize at 16,146, 3706, yes. And then 4916, 2768, yes. And 273, yeah, okay. Unexpected input, line 4. So it's this one. I feel like do I want 2 here? Unexpected end of input. I suppose I could do that. I think that's what I did last time. Let's see if we can get just one. Okay, I can't find the button. I'm gonna do this. I don't think, oops. I don't think that this is necessary, but maybe it's different. No, same result. It expected the end of input here because it didn't parse anything. Okay, let's go one step at a time here. I'm going to go back to this. Let's comment out all these expectations. We're going to import parsing here. And then I can say we're going to parse button A. Let's just do button and then can I do that? No, I can do okay, we're going to map this. No, we're going to parse our input, and then that's going to be our output is this. And then let's expect the output is equal to A. Expected end of input. I mean, how do I just say eat the rest of it? There's prefix, and there's no sum. Maybe I just do prefix true. And then this is expecting oh, it's giving me the skip. There's got to be a better way to do that. All right, so then let's do A colon, and then let's grab our point parser. And then we'll skip everything else. And we're going to make sure that our output is equal to a point with 5111. Okay, that works. So now let's take the claw machine parser and just try to parse one claw machine. We're going to say claw machine dot parser in day 13. Okay, that needs to be equatable. Okay, claw machine parser works. It's something to do with our new lines. Button point, map, claw machine. I wonder if I just do many like this, if that'll work. Oh, it did not work. It failed. Coordination expectation output claw machine. So it got 51, 11, 38, 78. Wait, did I type those wrong? 51, 11, 38, 78. Yeah, I did type these wrong. And 16146. 3706. Okay, unexpected input, line 4. I'm not sure why that doesn't work. Why the single line didn't work. If I look at if I do this, just give me anything here, then map that, then I get a claw machine and then the rest here. And I want to print out the rest. So the rest starts with a new line. It's so weird. I already tried this with one separator. I get the exact same error. All right. Let's see. What am I missing here? Consumes everything to returns the subsequences output. So that's rest. That's what I needed instead of the skip here. This is rest. New line is deprecated. Use whitespace 1 vertical instead. Are there examples here? No. I mean, I suppose I could have my separator as not a claw machine, but that seems really weird to me. Sorry, that's this. All right, so now I actually have to solve this puzzle. We need a part one static func. Part one takes our input This throws and returns string. Try parse input. We're going to return an empty string. For each one, we're going to solve the machine. Machine.solve is going to return, I don't know, button counts or something. What do I want to return here? I guess the count of buttons, maybe. And then we'll say maybe we return button counts. I'm not really sure right now. So let's go to our, not that. Let's go to our claw machine. This is going to return 2 ints. It's going to return number of A presses and number of B presses. Okay, just looking at the input here, we could have maybe the... Oh, there may be a case where this is not solvable, so that needs to be optional. So if A increases, no, this is wrong. I mean, I suppose I could do a for loop starting with 0 and going to our max number. We want to push A is the cheaper one, right? Oh no, B is cheaper. But B moves more in the Y direction. At least for these two. I'm not seeing a good pattern here. So let's say I tried to push A as many times as possible. So here I would say try pressing A. That's going to take our... We need a current X and Y. So if x plus a dot x is less than prize dot x, and y plus a dot y is less than prize dot y, then we'll press A. Count A plus equals 1. X plus equals... actually, let's just do a current point. If current, then we can say... Yeah, we can't do less than for that, so that's going to be current. Yeah. Then we can say current plus equals A. Because we can't just favor one over the other. I suppose if we need to figure out which dimension is bigger. So in this case, x is bigger. In this first case, x is bigger. So we want to favor pushing this button as many times as we can. But at some point, we're going to get to the point where, you know, if I do 51 times 20, 16,000. Is there no input for... Oh, this one, there's no valid input for this one. So we know for a fact that if the... Let's just say solvable, else return nil. And solvable is going to be if either of these numbers... So if prize.x mod divided by a.x is greater than our max iterations, or prize.x divided by b.x is greater than max iterations, or prize.y divided by a.y, prize.y is greater than b.y. So in this case, 16146 divided by 51 is definitely greater than max iterations. So this will return, that needs to be okay, so this first one is not solvable. Not solvable. Throws. This is going to return, let's take our claw machine. Claw machine. That's going to be A is going to be 51, 11, 38, and 78. 16146 and 3706. Okay. Expect not machine.solvable. And we also expect that machine.solve is nil. Okay. Let's focus on some input that they give us, which will maybe help us guide us to the right answer. So we're going to start with this instead. So that's parsing. We're going to do test func example, part 1 example. Throws. All right, this list describes a button configuration. Consider the first machine. Pushing the A button would move the claw 94 units along the x-axis and 34 along the y, 22x, 67. It would need to move exactly 8,400 units along the x-axis and exactly 5,400 units along the y-axis to be perfectly aligned with the prize in this machine. The cheapest way to do this would be A button 80 times. And I think, so we take the one that is bigger. Oh, this one, I just know I'm going to run into problems if I say push A as many times as possible. I think at that point, I would do, say, 8,400 divided by 94 gives me 89. So I could push this 89 times, but then that will leave me with a remainder that is not divisible by this one. So maybe I start there and walk backwards. So if I did something like let's do the maximum that we could fit in A is going to be, well, but it also depends on the larger number. Because that's the one we want to start with. Let's see, I want to take the maximum of prize dot y divided by a dot y. If I did that, this would be 94, 8,400 divided by 94. That gives me 89, and then 5,400 divided by 34 gives me 158. I actually want the minimum number. The minimum number of iterations as I'm pushing the A button. And then the same thing for B. And then I basically want the minimum of these two. Like, how many times could I push the A button? How many times could I push the B button? A is more expensive. So I feel like if I'm trying to get the minimum, then I would want to like maybe multiply this by 3, which would give us the cost. All right, if max A is less than max B, let's just try to do the one that has the biggest effect first. Otherwise, we're going to reverse it here. So here we're going to take, we'll take our current point and we're going to set that equal to I think I need to move this out. Okay, we're going to favor pressing A. If we're pressing A, let's call favor A. Then we're going to start with, and this is an int, right? Yeah. So we're going to do maximum number of A times A's cost. This is just going to be a point. Okay, and then otherwise we're going to do current equals B times max B. Okay, and then this iterations is going to be max iterations minus whatever max we chose. Because we're starting by jumping ahead as far as we can. We need to know if the remainder is divisible by the other button. If current is equal to the prize, then we break out of our for loop. Count A. Count A here is going to start out with max A. Count B, max B. So I'm basically going to walk backwards from the number. So if I did 8,400 divided by 94, I get 89. So I'm going to start at 89 times A. And then I need to walk backwards, which means my for loop is actually wrong here. I'm not sure what I want to do with that. Let's just do while true for a second until I figure out how we're going to break out of this. So, let's see. If we're favoring A, then we need to check to see if the remainder is prize minus the current point. We need to see if the remainder is divisible by B. If it's not, then we can't solve it with this one. So if the remainder, I'm thinking mod b.x equals 0 and remainder.y mod b.y equals 0, then we can solve this by pushing b interesting that those two numbers would have to be the same, right? If one number is divisible and the remainder is 3, and the other number is divisible but the remainder is 5, then we can't solve it by pushing that number. They have to be the same. So then we're going to have to say if that and remainder dot x divided by b dot x equals remainder dot y divided by b dot y. We can solve this by pushing this that many times. So count b plus equals remainder dot x divided by b dot x, because those are the same. We need to make sure that none of those are 0. I would not be surprised if there's some zeros in here. Not found plus 0. Okay, well that's good. Let's just make sure that zero and b dot x greater than 0 and b dot y greater than 0. We can handle that if that becomes an issue. Okay, so if we're favoring A and this number is completely divisible by the remainder by pushing B, then we can solve this and then we're done. If we can't solve this by pushing B, then we need to subtract we need to subtract 1 from count A. We're going to say current minus equals A. Then we're going to go through the loop again. We're going to do prize minus current, see the remainder. We're favoring A, so we're going to keep through this loop until we go down to 0. I feel like there's all these special cases of like, there's maybe going to be some puzzles where you only push A, and some puzzles where you only push B. But some puzzles where they're completely factors of each other, so you would really want to solve it by pushing one of them, the cheaper one. I don't know if this is going to work, because then I need to, if we're not favoring A, then we need to invert all of this logic. So we're going to do A here. Then we can solve this by pushing. That's otherwise we'll backtrack on B like that. Okay, if let's see, count B is less than 0, or count B is less than 0, then we need to break. Or return nil, because we're done. This seems horrible. Let's try it and see what we get. This result is supposed to be so most prizes you can possibly win is 2. Minimum tokens is 480. So that's gonna be throw. Okay, let's double check where we are so far. I can already tell that this one is probably not going to be done today. Okay, so this first one should be solvable. And it says it was not solvable. Okay, so we already have a problem. I think that I want to I'm just gonna let's write another test here. Test Unc part 1 example 1. We're going to do this. We're going to get the machine equals try day 13.clawmachine.parse. Parser.parse input. Okay, so we have our machine. We expect this to be solvable. And we expect the number of times we would push this 80 times and 40 times. So this would be 80, 40. I really hate that tuples can't be equatable like this. Seems like a strange requirement or sort of strange limitation of the compiler. So we're going to say solution.a is 80 and b is 40. Can I do require like this and have it return the thing? This can throw. Expectations failed. Okay, so the first problem is we're not solvable. Okay, so here we're going to do prize. Our prize is 8,400. Prize.x divided by a.x is 89. I guess that this is definitely wrong. I want to say that if one of the buttons is too small in value to push, that doesn't mean that we can't solve it. It would be if both of them. Yeah, I don't know if I can do this. I'm gonna get rid of that for now. Which means that in my test, we can get rid of this solvable part. And we'll just let the algorithm take care of it. All right, these are lets. I don't need that. Okay, maximum number of times I can push the A button is 89. Maximum for B is 80. So we're going to favor the B button. That's not right. Why would we favor the B button? I suppose I could run it both times and just see. Run it with A first, then run it with B first, and see which one is better. But I feel like there should be a better... There should be a better way for me to... Well, maybe I do need to favor B, and it's going to start at 80 and walk backwards 40 times. So if we favor B, the remainder that we have is equal to the prize at this point, so it should be... Oh wait, no, I started at B. So B times 80 is 66, 40, and 40. Wait, that can't be right. What is our B here? 22 and 67. Oh, okay. That makes sense. Okay, so we are, yeah, the remainder, we have 40 points to go in the Y and a lot to go in the X. So clearly this is not a great strategy, but we're checking the remainder. A does not fit in that remainder, so we're going to subtract. Okay, and we're going to have to do this a bunch of times. Oh, it jumped out. What? How did it already give me the correct answer? I thought for sure this was not going to work. Count A, count B. Okay, let's run it. This does not make sense. There's no way that that's correct because I don't have a, or where am I returning? Okay, so now our count is 40, and we can add it exactly by adding A that number of times. Wow, it did work. I must have just hit the wrong button. Color me surprised. Okay, let's take a look at the second example. This one is here. No, come on. I think there's some like weird JavaScript inside of this text area, which is trying to help you copy, but isn't helpful. Okay, so at this point now we expect the solution for part, there's no combination, so this should be nil. We're going to expect that that equals nil. Okay, we got something. No, it didn't like our input. Yeah, there's a space at the end. Okay, that one worked. Let me go get rid of that. let's take a look at example 3. Okay, example 3, 3886. So I need to do this. 38 and 86. Okay, so now our part 1 is going to take all of our button counts, and we're going to map these to their cost. So it's going to be A times 3. Yeah, A times 3 plus B plus B. So that'll give me all my values, and I can reduce this with 0 and plus. Let cost is that, and then we'll return string cost. This is going to be let's see, we're going to compact map, maybe. Compact map $0. Let's fix up the indentation here. So we'll map each machine to its solution, which we can do with machine.solve. We can just do this like that. Then we can map that to its cost. Okay, let's try this with the puzzle input. All right, let's see if this is correct. That's the right answer. Continue to part 2. As you go to win the first prize, you discover the clause nowhere near you where you expected due to a unit conversion error in your measurements. The positions of every prize is actually... Oh, that's funny. This is going to be hilarious. It's higher on both the X and Y axis. Add, what is this? 1, 2, 3, 1, 2, 3. So that's millions. Billions. Yeah, what the heck? How does that change our input? I don't know if it does. We just have to multiply the number of steps it takes. Now, it's only possible to win a prize on the second and fourth claw machines. Fortunately, it takes many more than 100 presses to do so. Now it is only possible to win a prize on the second and fourth claw machines. Many more than 100 presses to do so. Using the corrected prize coordinates, figure out how to win as many prizes as possible. Okay, so there has to be some kind of shortcut that we could take. So the prize needs to be multiplied by, no. Okay, so in part 2, we can just mutate. We can do, say, var machines. We're gonna map. No, we can just do this. We're gonna create a new claw machine with a machine.a, machine.b, plus a billion. No, this is more than a billion. That's millions. That's billions. 10 trillion. Lovely. I'm either going to get some integer overflows or this needs to be that. Okay, so there's fewest tokens you have to spend to win all possible prizes. So we don't care about the 100 anymore. And I wonder, did I even have that in my input for part 1? Is max iterations used in here? No. We just said we can't go less than 0. All right, let's see what happens for 13 part 2. Maybe my machine will blow up. We're doing lots of iterations, but we're just doing math inside each one, so we should be able to do quite a few. I just don't know. Maybe I don't know if I should be printing anything in here. That's going to make it go so much slower. I just don't know how far we are. Let's set a breakpoint. No. Set a breakpoint here. Let's see. We have I think it's this problem that we have to walk backwards so far. I feel like we could probably take a bigger step. But I'm not sure how I would know. Yeah, it's pegged my CPU. Certainly we could do this in parallel. Yeah. While this is running, just because I don't think I am reaching a solution that is better than what I have, and I don't know if this may run for hours. I have no idea. But while that's running, I do want to take a look at some other solutions to see how other people did it. Okay. Amazing. I don't know how to... I don't think in linear algebra, so... You can derive it pretty easily with a bit of basic algebra. The problem you have to be careful for part 2 is you have to avoid using division until you've already determined that the solution generates integer answers. Because the floating point error gets unmanageable when the numbers are that big. So you need to find a coefficient times a equals right hand side where a coefficient and right hand side is both integers, and then check modulo. Of course, this ends up being you deriving the determinant of the matrix yourself. Okay. So what we're doing here is dividing every step through. The numbers are gigantic, so these remainders maybe aren't that accurate because of the floating point precision. Okay, doing top of equation, mod bottom of equation. What does that mean? Before I was doing final value frac less than epsilon, which work for small numbers but not big ones. That's all integers and 2 divisions at the end where the modulo tells you in advance if it's good or not. No need for floats or matrices or anything. Okay, so what we're doing is iterating, and what a lot of other people were doing is just dividing. Our iteration is clearly not a great solution because it's still not done. This is prize y times a of x minus prize x times a of y divided by b times by times a of x. Does that work? interested in that. Don't want to interrupt this. I kind of want it to keep running because I'm not, well, I suppose I can interrupt it and see how far along we are. 6, that is still in the millions. We're at 147 billion. So we've gone through trillions of executions to get here. I feel like we have gone most of the way through it then, if that's the case. I'm super curious about this other solution. Let's open up a Swift REPL. So we're gonna do that. So the prize Y is equal to this number plus what was our sample input here? Second and fourth claw machines. Okay, so let's look at the second and fourth. Yeah, so this one. Let py, let px equals, oh, that was px. Let px equals the other one. 48, yep. Let ax is 26. 26. Let bx equals 22. Let ay equals, no, I'm doing the wrong ones. AX is 26. BX is 67. AY is equal to 66. And BY is 21. Okay, so now if I go back to this equation, let B equals this. Then let A equals that. Okay, well, at least we know that the math works out. Let's see where we are on our iteration here. Which one are we doing right now? We're favoring B. So our count B. Oh, I was looking at the wrong number. Let's see. 1, 2, 3. 1, 2, 3. So that's millions. That's billion. I still have 129 billion to go. And if I run this for, say, 10 seconds. Yeah, this is gonna take too long. All right, let's try this with let's do func solve improved, and this is gonna do this thing. So we're gonna let B equals prize.x. This is going to be count B. Prize.x times A.y divided by B.y. A.x minus B.x A.y. Let count A equals this. All right, 1 second. back. All right, I'm back. Okay, so now count A is going to be prize.x minus B times count B times B.x divided by A.x. Okay, we're going to return A is count A and B is count B. That needs to return our tuple. This, how do we know if this doesn't work? Somehow I need to know. So if I do this one, this is going to be solve improved. Let's run it again. That was quick. Much better than my solution, but I don't know if it's correct. Not the right answer is too high, so I think let's see, what is that one? That's all integers and 2 divisions in the end, where the modulo tells you in advance if it's good or not. So I need the modulo to see if this works. Helps checking if the denominator divides the numerator, so you can discard non-integer solutions. So I need to do that here. I don't know what to call this top part. I'm going to call this M, just for lack of a better name. And let this be N. So I can do M over N. Then I'm going to say guard M over N equals 0. Mod N equals 0, else return nil. And I probably need to do the same thing for the other side. So we'll do QP, I guess. Let Q is this. and let p equals a dot x. Guard q mod p equals 0, else return nil. That one needs to run first. Okay. Okay. Wow. I don't think I ever would have figured that out on my own. But I mean, this is a learning. This is a learning exercise. I think it's okay to attempt to do it yourself and then try to learn from the solutions. The thing that I don't understand is how you reach this point. I mean, obviously I can read the expression. I understand that we need to bail out if dividing these returns a non-integer number, which means there is no solution for that row. And what we were getting before is partial button presses and rounding them. That's why that was giving us an answer, but the answer was incorrect. So just looking at this equation, prize.y times a.x. This part is strange to me. b.y times a.x. Okay, this is defining like a dimension, and then we're seeing the relationship between the two buttons. Okay. And that gives you the number of B presses. And I guess we're favoring B because it's cheaper. And then once we have B, we can press A the remaining number of times, which is, yeah. So like we already know that this is a valid solution. I think I don't need this. I think I will get the same value, 958,439. 827. Yeah, so we already know. So I'm gonna inline these for no, that a.x. We already know it's a valid solution because we did this part. And at this point now, the count B, we know that it fits exactly. And so now we just need the remaining value of once we have done the number of times we're going to press B, we're going to choose one of the dimensions. I could also have chosen, let's just do assert that count A also equals prize.y minus count B times b.y divided by a.y. This should always hold true as well, because it doesn't matter the dimension we choose, because we already know that it fits. Interesting. Okay. Yeah, that was a tricky one. I'm definitely going to give credit to this person. No. How do I get a link to the exact one? Yeah. Share it on Mastodon. Yes. This is going to be courtesy of Spider Hater. I also hate spiders. So, was it Spider Hater 4. Okay. All right. I didn't actually think I was going to get that one in today, so that's good. All right, yeah, so that's it for day 13 of Advent of Code. I will not be streaming the solutions from this point onward, I don't think, because of just schedule and travel and holiday stuff. So anyway, thanks for coming along this journey. And if I do end up solving the solutions, you can find them on my GitHub. I have all of my solutions for this is in Advent of Code. What did I call it? Advent dash. Looks like I have some. It looks like I have some extra junk in this directory, which I need to prune. But yeah, all my stuff is here in in 2024 Swift. Quit. How do I quit? There we go. Add dot day 13 push. All right, that's it. I will end the stream here. Thanks again.